Okay, continuing on with class 10, here is the third video, and we're going to deal with another example out of Munson's book. This has water flowing through this horizontal branching pipe, so this is in the horizontal plane. So there's not going to be any z's. All the z's are the same in this. We're looking down upon this. And we have a flow rate of 10 cubic feet per second coming in here at 1. We're going to ignore viscosity, and we're going to determine the water speed in section 2, the pressure in section 3, and the flow rate coming out at 4. We assume it's out at 4 because they drew an arrow right there, but we don't actually know. So let's see. We'll remember what the density is, 1.94. And I think actually we could maybe cancel out the density here, but let's go ahead and put it in there anyway. And I'm going to use what I call Bernoulli 1. And because, let's see, I know a lot about 2, we could probably go at either spot right here, right? So we'll work through 3 in a minute. Let's just start with 1 to 2. And in an engineering problem, any engineering problem, if you don't immediately know the procedure to get there, just try something and see where you end up, and then kind of reevaluate. So 1 to 2 sounds like a good place to start. So we go P1 plus 1/2 rho V1 squared plus gamma Z1, which we already know we're not going to need, but we're going to write it anyway, plus 1/2 rho V2 squared plus gamma Z2. And we can cross these guys out already. And P1 is given to us. So let's go 10, but it's PSI, so let's multiply it by 144 because we want to deal with everything in slugs and feet. And then 1/2, 1.94. As I mentioned, that might actually cancel out some things, but that's where we're going to leave it in there anyway. And V1, we're given, nope, we don't know V1 yet. So we need to come back to this. We do have the area. So I'm going to put a pin in this, and I'm going to come down, and we're going to come back, right? And this is sort of like an example of what I was mentioning before. Like if you don't know exactly what you need first, just start and then start seeing what you need. And then say, oh, I can get that. So we can get the V1 is going to be the volumetric flow rate into 1 divided by A1. So that's actually pretty easy to do right there, right? Because we're going to have 10. They're using Q, but I'm using this stylized V right here. And we know that it's going to be 10 feet per second, right? Because we had cubic feet per second divided by feet squared, so we had similar. Okay, so we had 10. Yay. And I'll leave that out. We don't need that. We have the pressure at 2, right? So the pressure at 2, which is 5, and it's going to be times 144 as well. And then plus 1/2, 1.94, and then we have V2 squared, right? So we'll be able to get V2. I should mention, if we used Bernoulli 2 instead of Bernoulli 1, this is Bernoulli 1, we might have been able to get rid of the density in there, and gravity would have just been, in there? I guess gravity would have been in there. Yeah, but it would have been okay. It didn't matter. So anyway, no, I think we did need it. No, I don't think there's any way to have gotten rid of it. I'll take that back. I think we did need to have it in there. Excuse me. Let's see. 5.8 feet per second, right? So we see this like 2.8 times what it was coming in terms of the velocity of the thing. But let's find out what the volumetric flow rate at 2 is going to be. That's something we might want to know. So let's take V2 times A2, and we're given that that's 0.07. So 28.58 and 0.07. And what we're left with is, where'd I go? Where'd you go? Oh, no, okay. 2.001. We could just think of it as 2. It's probably a round off error somewhere in there. I think they did this on purpose. All right. And while we're at it, let's go to 3. I think that's fine. Let's, we get the volume flow rate of 3 too. we're going to need this in a minute, so we'll just go ahead and get it. So they gave us the velocity, and they gave us the area, so we could have done. They could have just been nice to us and have given us the volume flow rate too, but we can find it right here. And anyway, we find out that's going to be 4, right? Cubic feet per second. So we could actually jump to this last one right there if we wanted to. We could say V1 is going to be equal to V2 plus V3 plus V4. So they gave us the volume flow rate here as 10. We just found this to be 2.001 for all intents and purposes, 2. This is 4. And then we could find V4, easy enough. If you just stuck with 2 sig figs, you know that this is going to be 4 cubic feet per second, right there. So we answered the third part of it there first. Now we're going to answer the second part. We want to find the pressure at section 3 right here, right? So they gave us the velocity in the area, but we didn't know this pressure. We could once again use Bernoulli 1 in there, but now this time, and by the way, no, it's probably best, we should go between 1 and 3 because there isn't really a streamline that's coming back into there, right? We should have a streamline along this line. We should obey the idea of Bernoulli that we can only do things along a streamline, right? So we have streamlines that are branching off right there. So we have a streamline that does connect 1 and 3, so we can connect these two together. And I'm just putting this in here, just we want to keep consistent here, I should say, when we're doing our equations and being consistently thinking our way through the problems as opposed to just plugging numbers in. We know those are going to cancel out though. And I think we had 10, and we have 144 there, and then we had 1.94 for water, and we had 10 here as well, 10 feet per second squared. And the pressure is what we're trying to find, and we just found, or do we know? No, we were looking for 3, or no, we were given, okay. Yeah, so 1.94, and 3 we were told was 20 feet per second. And that's it, right? And so we can solve for 3, the pressure at 3, which ends up being 1,149, and these are pounds per square foot, remember. So divide it by 144 inches squared per foot squared, and what we're left with is 7.979 psi. We could assume this is psi-G because unless there's a good reason to, most everyone always reports pressure. When they say psi, they kind of imply psi-G. So we might as well go 7.98 psi. So there's our answers. And I really prefer that you rewrite them and put them at the bottom, but I didn't this time. So this is a shorter video. That's okay. Short videos are good. And we'll look and do a couple more. I think I'll have just one last video here because I only got 2 pages worth. So I got, no, maybe I don't know. We'll see what happens. See you soon.